in this Saturday's weekly program, which we are organizing since last more than a year. Today, the subject is how we are recording the human blood pressure. We have with us Professor Dr. Ashok Kumar, senior scientist from the National Physical Laboratory, who is working on this project since last many years, and he has developed a new device for the calibration and testing of blood pressure measuring instruments. We have with us our Joint Secretary Sir, Honorable Joint Secretary Sir, who is always with us to support us and guide us how we can do better in the field of legal metrology. So today we have the subject which is basically linked with the human health, the BP meter, how to calibrate, how to test the blood pressure meters. National Physical Laboratory is working since last many years on this subject. They have supplied 2 blood pressure meter testing kits to the regional reference standards laboratories, one at Varanasi and one at Ahmedabad very recently. And we are planning to buy or install some more blood pressure meter testing kits at other RRSLs. We have with us Professor Ashok Kumar. Sir, kindly inaugurate this workshop for today, please.
Thank you very much, Ashutosh ji. Good morning to all participants and a very happy Diwali to all the attendees. We have a great expert from NPL, Shri Ashok Kumar ji, who will be talking to us about calibration of especially the blood pressure meters, which are now easily available in the market. And earlier we had the analog kind of meter, and possibly that was seen with most of the medical support staff as well as the doctors. But now our country is flooded with a large number of electronic blood pressure human measurement meters, and these are largely being imported. Some are also manufactured domestically. But it becomes extremely important that the meters which are available for common consumers across the country and who depend a lot on a daily measurement of their blood pressure, they are well calibrated. They read the right, let's say, the readings, and they give the right blood pressure, because it is extremely important in the medical interventions for any treatment related to hypertension or low BP and other things. Besides this, you would have seen that in the earlier days also, there were many models which were available for other similar kind of measuring instruments, like the thermometer, which also used to come analog. And we had some 3 or 4 thermometers, and every thermometer device gives a very different kind of a reading. And we were wondering whether my temperature is 98.6 or 8 or 9, or so there were marginal differences in the calibration, reading and measurement. And that is what we are right now talking about. And we have a great expert here who will be talking about this. My simple point here is there is a large population in the country, and the use of these biomedical, medical instruments which support human life largely is going to increase. And we need a lot of industry to support and domestically manufacture these meters. But their accuracy is of extreme importance, their calibration, the quality of these meters and their output readings, input mechanisms, and the maintenance to a long extent without being, there has any safety hazard also is to be seen. So our manufacturers are certainly encouraged to support, because there is a boom of population across the world and domestically, and a medical BP instrument would be required by everyone. On the other hand, consumers should be made aware about what are the meters which are very good, which are domestically available, and what are the indicators they should possibly look at before buying a well calibrated and manufactured or imported blood pressure meter. So with these words, I think if we have a medical expert also on this call, it will be very nice to listen to them also, because they are the actual users of these kind of instruments. But nevertheless, we have industry, we have consumers, and we have our own expert and they will delve deeper into this subject and enlighten us with their knowledge here. Thank you very much.
Thank you, sir. Thank you very much for your kind words, sir. Now, I would like to request Professor Ashok Kumar, the senior scientist from the National Physical Laboratory, to kindly come into the picture and start his presentation. Professor Ashok Kumar, who has a lot of experience in this field, and I know him since last many years. When we were developing this new device, I was closely associated with him, making this patent and all. So, sir, Professor Ashok Kumar, kindly start, please.
हाँ गुड मॉर्निंग आशुतोष जी
11 बजे
हैं हाँ वो तो मैं माथुर
दीक्षित साहब का माइक ऑन है। अ, दीक्षित साहब, जब तक हम दीक्षित साहब को सुन लेते हैं इस विषय
please,
में।
sir, please, please. Sorry, sir. I think there is some communication gap. He's just trying to bring into the picture, but I think he's not able to share his screen. He's just trying.
no you see that the
Sir, you
blood
please speak. You please speak. Please.
हाँ, so the blood pressure meter is the topic of today, and this topic is very important because due to health problem this blood pressure measure is being used by most of the families in their houses, even from middle class and lower class, and there you may get the different type of models in the high class families because everybody is in tension due to uh, due to their work and schedules. So sometimes even the people do not know that how much they are in the pressure, and they feel uneasy, and that may be due to the heavy blood sugar, that may be the due to tension, or that may be due to the scarcity. Some there may be any other reason, examinations are there, and the competitions are there for that, those very things are there. So whenever we are observing anybody in our family and that he is feeling such tension and other type of things, we must measure his blood pressure, and if possible, then we should provide some medical help. This used to happen in most of the families also. Sometimes it is also happening that the people are of the sugar patient, people are taking the sugar pills every morning and every evening. Even in my house also, some of the people are taking. So what is happening there that they are finding that they have not taken the pills, and in night they used to say that they are feeling some uneasiness and all this type of things. So I am asking that have you taken the pills and of sugar and other medicines? So uh, since they have not taken, so they will tell lie and nothing other than that. So I used to say that you take once again because this things has been developed, so this problem will be resolved. Plus we are taking the blood pressure also जो है, then whatever the medicine we have in our house, we are providing that very thing, and if it is more than that, then we have to go to the hospital. During the winters also जो है, you'll find that some people are sweating also. uh, it is unbelievable. So these are the cause of the tension. And some young people, they will say that no, this is my temperament and like this and this and this. I used to have every day like this. Don't worry for that. So this is not the good sign. This is a bad sign because the science is same for the everyone. It is not
Start
varies
video.
from
Okay.
man to man, man to man.
You know,
I
the
think
Mac having
Mr.
also a lot.
Yes, sir. Now
Yes, no,
Mr. Ashok Kumar has
Good,
come.
good
yes.
morning, Ashutosh ji. Good morning.
Good morning, sir. Good morning, sir. We have with us our Dikshit Saab. We have with us our Joint Secretary
Good
Saab.
morning, Dixit sir.
Good morning, sir.
Good morning. Okay, great. So let me, let me join the. I have to upload, share my PPT. First, I have to bring PPT also. Give me 1 minutes, okay? Just 1 minute, okay? 1 minute. Okay, so this is great. Let me share my document. Allow Wex to share your content, open system purpose, because Mac having lot of problems. They have lot of security part. So they have every time it requires permission. If I want to share something, then also grant access in system preference.
Otherwise, you kindly share WhatsApp or email it to me so that I will immediately start sharing from here.
Yeah, this is big file. It cannot be shared. 1 GB file having videos and other things. So it's large content. Just a moment. I'm trying my best. It was not the problem. Allow. Yeah. I don't know. You have also a lot of things that is security part from your the WebEx. So you should have the normal earlier.
Otherwise, sir, you share the PPT to me, then I will share the PPT.
No, that can, because it's a large file. It is like 70, 80 MB file. How can I
Please share
share
on
that?
WhatsApp. Please share on
Huh?
WhatsApp. Please
What?
WhatsApp.
What do you say? Hello?
Please share
WhatsApp,
the
WhatsApp.
PPT on WhatsApp.
WhatsApp. Can I do WhatsApp?
Yes, sir.
Yeah.
Yes, sir. Please.
Okay, I have already shared the PPT. Let's check. आशुतोष जी हमने आपको भेजा है. You
Oh.
just check it.
Okay, sir. Okay. Sir, can we share this PPT to the participants after the program?
I don't think so, because a lot of datas are not published. So
Okay.
this is
All
not
right.
meant for any, only for you, because you told yesterday. That's why I was ready. It was ready for. There are many data which is not
No problem.
published,
No
so
problem.
it should not be shared. I believe so right now.
No
Maybe
problem.
later sometime.
No problem. No problem, sir. No problem.
Ashutosh ji, let's let's use this for the presentation,
Yes, sir.
and we will
Santosh.
respect
sir.
the research available.
Sir,
Yeah.
sir.
Thank you.
Santosh ji, I have shared with you.
Okay, sir. Sir, PPT is visible, sir?
Yes, it is visible.
Sir, please start.
Okay, so can you hear me? No problem.
Yes, yes, sir. Go ahead, sir.
Okay, so this is full screen. I think something is resized to change the video size or number of videos. Got it? Something you have to click. Okay. I don't know. Lot of things that. Okay. So, good morning, all of you. This talk I have prepared yesterday. We had a colloquium. Can you hear me?
Yes, sir. Yes, sir. Go ahead.
Don't change the I'll tell you change the slide. So the first slide. So this especially we have prepared this talk for the NPL colloquium, and where we have developed some of the devices which is really related to the legal metrology, and we have worked for legal metrology since the last 2.5 years. I would like to thank Ashutosh ji and Dikshit ji for such a wonderful support for this particular journey. And I am happy to announce that we have delivered two of our system for the RRSL Varanasi and Faridabad, and future also. But meantime, we have discovered and developed many things which is really useful for only legal metrology, I can say. So this talk I have not I have designed for I don't know who are the audience, but this I will talk like a general audience, maybe which is literate, illiterate, or legal metrology officers, or maybe inspectors, and for them also it will be very useful. So could you please change the slide? Yeah. So the talk contents the theme line of the brief history and the physiology of the human blood pressure. So for any, either you are a researcher or you are a, officer, this knowledge is essential. Then only you can have a better, handling capability. So I'll talk about the brief history of and the physiology related to the blood pressure, and then I'll talk about the various types of the blood pressure monitors existing in the market. And the third, what are the international guidelines for their testing and type approval of these devices? So these three things, and apart from that, we have developed recently a blood pressure recorder. Why it is required. That also I'll talk. And hopefully this month or coming month, our indigenous blood pressure devices, which is for the home people, they are using for the every day you are buying the that we are testing and calibrating. So the same CSIR, I think we will be able to develop that devices based on our understanding, and then I'll describe why it requires, because still we are not doing the good job compared to international market. And the third, uh, blood pressure simulator, and we are in process of developing indigenous simulator, although we have the simulator bought from the Fluke and other companies, and why it is also required, and what is the status of the various NMIs in this particular and then we have developed various pressure sensors also, which is especially designed for the blood pressure sensing devices, because pressure having range from the gigapascal to micropascal, and one sensor will not use for everywhere. So we have developed some flexible pressure sensor that will be useful, and I'll demonstrate you key how it is useful and how it is good for all the particular R&D purposes and the technology purposes. Please change slide. So if you look at this particular slide, in 1733 the first discovery was done by the Stephen Hales, who measures the blood pressure on horse, on animal. And this discovery laid the foundation of the blood pressure. Then the next milestone was the discovery of the mercury manometer, by the Poiseuille, and in 1828, they discovered, this you can measure the barometric pressure. You have the YouTube manometer, and you can generate pressure. And this is the discovery of the real instance of the. And then 1854, the Vedrat who invented the sphygmograph. This sphygmograph is also related to the pulsation of the blood. Blood is pulsating, and that's the. So these are the milestone. And then 1856, the Favre, who accurately measured the blood pressure of the human. So this was the first time any person, any scientist who discovered, who accurately measured the blood pressure of the human being. And then the next milestone was 1876 by the Itimi, Jules and Mary, who discovered the oscillometry. Oscillometry and the most of the device which is existing in the market right now, 96-97% are based on the oscillometric technology. So I'll be especially focusing on this particular blood pressure devices, which is really used by the company which is selling in the market, and the necessary for their calibration and testing and type approval, which legal metrology is doing. But this is the time they during talk I'll talk where we are lacking, how we can strengthen this particular testing and type approval. And now it's not we do not have the technology, or we do not have the a condition for that particular things. And then the next milestone was the invention of the modern blood pressure cuff. And this was none other than the Riva Rocky, who was one of the jubilant scientists who invented this modern blood pressure cuff. And then you all aware of that. I think legal metrology is dealing with the blood pressure, mass, and all the things. So everybody is, those who are participant, everybody is knowing about the Krotokop sound. And the Krotokop is nothing but, if you are doing the manual or mercury sphygmomanometer, then you will hear the Krotokop sound. So that was the first time, 1905, it was discovered by Krotokop. And then the another important milestone, although this was not a discovery, but it was a kind of popularity of hypertension. What do you mean by popularity? Earlier that it was not as popular due to hypertension, people having can cause death or having some real problem. So this was the president of United States of America who died due to the hypertension. So this was a very high moment about the understanding of the blood pressure, and the worldwide people started investigating why this blood pressure and how it causes the human organs and other things. So 1945 was the another milestone for in this journey. And then 1976, the first oscillometric based blood pressure monitor was patented. So this is one of the another milestone. And 2003, European Society of Hypertension, who publishes guidelines for the ambulatory blood pressure. Ambulatory means nowadays, everybody is wearing the smart watch and the handcuff based, running devices, which is in situ will measure your blood pressure if you are running, if you are taking rest, or if you are. So this is ABBP, like ambulatory blood pressure measurement, and then the home based blood pressure. And recently to 2021, there is already the ISO. I'll talk about the ISO. They have already drafted the ISO for the clinical trial for the cuffless blood pressure monitors. So this is very important, because anyone is now, everybody is wearing the cuffless blood pressure monitor, smart watches. Most of the youngsters, or they are using these things. So this is the journey of a discovery of the blood pressure related, the equipment and the concept and the theory, devices, they're patented, and then their protocol for the testing and type approval. Next slide, please. So if you look this graph, this is the one of the marvelous, discovery by the Stephen Hells. That time, even you can understand, 1733, he was able to design a cross tube where he joined the brass with glass, because glass required only the glass is transparent, metal is not transparent, so they cannot visualize whether this really. So what they found, they put the brass U tube type of brass inside the ventricle of the horse, and then they found the blood of the horse reaches 8 feet 3 inches, and that blood was also, blood of the horse was not static, it was dynamic, it was rising and falling, rising and falling. So that time it was already established now the blood pressure is dynamic, and it has a systematic change, rise and fall, due to the compression and relaxation of the heart. So this was established by the Stephen Hells, and this leads to many other developments. So next slide, please. So you all aware of this modern sphygmomanometer. I think you are much better knowledgeable than me. Still the sphygmomanometer, that's the mercury based sphygmomanometer, is known as the gold standard for the blood pressure. It means you have a very accurate blood pressure measuring devices. But who discovered this? How he discovered that once. So I already told you Rivaroque, who presented the modern day techniques, which is used on this, and the Russian guy, Nikolai Krotokov, who discovered the Krotokov sound. You can understand the discovery is not led to, you are working 40 years, or you have the 400 papers, or you have these many things, but only 207 words, discovery of hypertension. So you can imagine if you discover something, a small description will be fine for to the change the world. So this was the discovery, the Krotokov, who wrote a paper of 207 words, and still it is relevant, like Mahatma Gandhi is relevant today itself. So these are the things that we should know. And then the modern sphygmometer was discovered, designed, developed, because technology is two different things. Understanding is different things, and then the development of the technology. So 1920, the modern mercury-based sphygmomanometer was, designed, developed by the Willing Midgate, and which is still known as the gold standard worldwide. And I'll come to the point where we'll discuss how it is, relevant to us. Please change slide. So all you are aware of the human blood pressure, where I don't need, but some of you attendee, not for the panelists, those who are not aware of the pressure, but I believe so. One torr is one. So what is the range of our blood pressure? Everybody is knowing, our systolic, what is the normal human blood pressure, 120/72, means systolic is 120, diastolic is 80 mm of Hg, mercury, millimeter of mercury. But in terms of the pressure, it is from the kilopascal, several kilopascal, like 5 kilopascal, 10 kilopascal to 15-20 kilopascal. So this is all about in the range of the human blood pressure. So all discussion today, 1.5 hours, I'll be talking only in this pressure range, because world is very large enough, and if I'll talk many things, you will not understand. So it will be better to confine myself in this pressure range where our blood pressure lies. Okay, next slide, please. So next is understanding people. I have several problems recently in the last 1 month. Two of our scientists who diagnosed hypertension. One day he reaches Gangaram, and the doctor, there was his blood pressure was 170 and 90, and he was diagnosed hypertension. Then he was very scary and upset. So one day, that is a kind of, everywhere in NPL is going, on. Now he is now HOD of the department and he got hypertension. So this is a kind of joke everywhere. Now if you're the HOD, you'll get the hypertension. So the device which we have developed, then I called him, okay, come, let's have check me, okay, whether you have really hypertension or not. So then why I found it's perfectly fine. 128 to 70. I thought, I told him, whatever I knowledge I have, you don't have anything. You are a very perfect and normal people. So so I am giving you example, and I'll come to one point, how, a faulty equipment can change the large number of demography which is not really sick. They become hypertension, the patient of hypertension, and some of them is really having the hypertension. They will be, considered as a normal. So this is very important part which I would like to convey you. So if you will see the chart, internationally recognized chart, means if you have on an average, every time if you are measuring like your blood pressure above than 150 mmHg, 140 mmHg systolic, then you can have a grade 1, or really not as scary, but you have to monitor the thing. This is the monitoring stage. But if it is more than 160, then it is having concern, and then you should think about the. So that I'll also talk. At a once you will get it 160 one time. Suppose that if you have fight with your family member, wife, husband, so ever you have, your BP may change. I'll come to the point and then you see how it is drastically change the blood pressure. So it is very dynamic. So that all thing you have to, so you have to monitor for a long period of time consistently, and then only you can come to some conclusion. So this is the range of the hypertension, above than 140 50 mmHg. Then you have the normal like 80 to 140 mmHg, and low, then you have the hypotension, means low blood pressure. So all this is the chart related to the, and then there are things that we should understand. Suddenly you'll get some value, and you should not scary, I have the hypertension or something. You have systematic monitor yourself for a long period of time, then only, and then I'll come to the point, you'll see how it is changing. Please change the slide. Next slide. So next slide is very interesting. Recent publication, Nature Review, Cardiology, and fantastic, present this particular observations. Look at this. Suppose that if you have a indigestion in food, your BP will get down. It is not true for everyone, but this is a general observation. Similarly, if you are taking the alcohol, the same alcohol, one person can maybe sedative, another may be hyperactive, means their blood pressure can change up to 24 mmHg, and some person can have down to minus 24 mmHg. What does it mean? It means blood pressure, if someone has taken the alcohol, that can have very, so that is also visible everywhere. You will see some people will take alcohol, they will be like down and not talk at all, somewhere lying in the street or at home. But some people will talk like anything, they will talk endless. So it means their PP or blood pressure is really getting larger compared to the some people. So if you have can see a individual, it is observation. Suppose that if you record your blood pressure for a whole period of time, then in a spring season or winter season, your BP will be large compared to the summer will be go down. So it can vary 10 mmHg. Similarly, you have the systolic blood pressure for one person to another person will be large. Similarly, if you monitor your blood pressure for whole day of time, you will see it. From the night and the morning, your BP will be low. But in the daytime, at the peak time, 12 o'clock, your BP will be large. And then the evening and night time, it will low. So this is all about, you have to understand. And this is all physiology that I was talking. Because the human physiology is such variable, it can vary like not 5 mmHg, which is the international protocol right now, but it can vary up to 10, 20, 30, up to 32 mmHg. So a person can vary their blood pressure due to their own physical, physiological change. The influencing factor I can see you are, if you are standing, if you are lying, if you are sitting, if you are, doing in something on different aspect, which is see, you can see all in this particular table. So these are this will be affecting a lot, so this thing we should take in mind. I'll come to the point how to take the real blood pressure data. Please change slide. Yeah. So this was the background. So first part is now over. What I want to convey the message to all the attendee, ki now we are not after this, background, how to discover blood pressure from the animal to human body to oscillation, and what are the basic things, how it will be effective, and how what is the definition of this blood pressure, geographical definition, physiological definition. So all this now aware. So these are the equipment, which is now available in the market. I have not included many other equipment because that will having a long list of the equipment. But there are two major technique. One is, invasive, and another is non-invasive. So today talk will be only for non-invasive. Invasive is quite different aspect because that is only used in terms of the emergency. If you have the heart attack, if you need some precise blood pressure near the heart, if you need the precise blood pressure during your any other surgery, like if you are doing the not only cardiac surgery, but if you have a, any other uh, complicated surgery, their invasive catheterian method is used, but that is not in the jurisdiction or preview of my talk. So the next is related to the auscultatory method, automated auscultatory method, or oscillometric method, alternative methods like infrared based sound technique, infrasound technique, ultrasound technique, impedance patho. All this requires, by the way, calibration, but that is also again complicated. It's not easy to you cover all the things. Then arterial tonometry, and then nowadays the modern gadgets, based on the 24/7 BP monitoring recording devices like cuffless, wrist, and arm based. So my talk will be focusing on only the oscillometric method based devices. Next slide, please. So, because as I told you, I am very much, not only I am a scientist, but also I have a, always enthusiastic. First, we should know the root cause in order to, implement something. So, in oscillometric method, what is the background for oscillometric? How it works, So, it works in the terms of the oscillometric waveform. So, our heart is always oscillating, pulsating, what due to the contraction and relaxation of the heart. So once you bind your artery and then you release the things, then it will give you the oscillometric waveform. And the people develop some algorithm you can also develop your algorithm, and based on the algorithm and the peak amplitude position, you can have your systolic blood pressure and diastolic pressure. So most of the devices which is in the market is working based on this oscillometric waveform, and they are using algorithm not based on the Indian clinical trial, based on the citizen of India. They have the data from either Europe or US or any developed country, including Omron. But this is now norm of the APMP. Most of the Asia Pacific Metrology Group recently they have mandated it कि each country should have their own data bank or clinical trial to get this oscillometric waveform. And in that, I am happy to announce that we have developed a device which can collect this oscillometric waveform. And I'll show at the end of my talk that is, and that is the first stage in order to go for any key comparison. I should have some data there, that is used for the, so because why they have taken this oscillometric waveform, because this is the backbone for most of the devices in the market right now. 2-5% you forget it, because it cannot be covered all the thing. So suppose that a device whose logic is wrong, they have not developed a good algorithm, or algorithm is based on the predefined some algorithm of Europe or US that cannot give you the correct systolic and diastolic value of Indian citizen. Okay, so we have developed this, and this is all about this particular so this is based on the mean artery pressure, and then the some percentage of mean artery pressure will give you the systolic value, and some percentage will give you the diastolic value. And the internationally protocol is there, it should be 0.45 to 0.8 percent of the mean artery pressure. And this is not my value, this is international ISO protocol, you should have in between that. So I'll come to the next slide where you'll understand how we have done all those things. So this is another important slide which I want to convey you guys, that you should understand if one device is not correct, you can make a large pool of healthy people become unhealthy, So they have one guy, this Turner, they did the survey on Canadian citizen, and they found they kept one diastolic value like 90 mmHg, and they found that some of the faulty equipment which gave +5 or matlab overread +5 mmHg, or the lower reading of the 5 mmHg. So they found that in reality their citizen only 8% were having hypertension, but due to the faulty equipment around it increased to 18%. But they have the limited citizen. But in case of India, where 130 crore people we are, suppose that if faulty equipment will be launched in the market, and the real hypertension patient in India is like 5% or 10%, it may increase to 25%, or vice versa. Suppose that it becomes unhealthy, people also become healthy. But suppose they have somebody having the real hypertension, and if some device will lower it down and say you do not have hypertension, you have only the correct value 90, so then it is very problematic. So they have done a systematic study, and they finally they conclude ki if your device is not calibrated, if your device is not providing you the proper blood pressure values, it may change a healthy population of a country become unhealthy, and even some of the unhealthy citizen of the country become healthy. So that is also probability. Suppose that if you have hypertension, and the device machine will tell you do not have the hypertension, then you will die, because that's the big problem. Both things we should consider. Please change the slide. So now this is the for the legal metrology. So there are three body in world which is right now taking care of the how a device will be perfect compared to the associated or reference devices. So one association is Association of the Advancement of Medical Instrument. It's called AAMI, and then another is European Society of Hypertension, and the third is the International Organization of Standardization. This is valid for all the all over worldwide. So they have developed this ISO 81060 2, and 3. Recently, 2022, they have already did the draft, and I made this guy Stephen Mike from the Germany, who is the pioneering in doing all the culmination of this ISO 81060 2, 3. And I believe legal metrology should have this particular ISO document. I do not have. If you have, you can share me. That will help me also to because then buying thing is will be difficult. It is not available in the market, but I have extracted this. So what it in the gist, this ISO is telling any device will be found fine in order to launch in the market if it has error of plus 5 Hg, and the standard deviation of the error is plus minus 8 of Hg. This is the gist of this ISO. What is the gist of ISO? The device which is developed or required for the type approval or for the testing, it should have the plus minus 5 mmHg error with respect to a standard device, and then in the error the standard deviation should not have large enough than the plus minus 8 mmHg. So I'll come to the point and I'll show you some of the data and how it is matching with the international ISO 81060 So the second part, that is Ashutosh ji is knowing well, because we are now following the OML guidelines, International Organization of Legal Metrology, R16.1 and R16.2, and this having still not clear about the dynamic calibration of the blood pressure devices, because most of the procedure which required for the type approval is based on the not dynamic mode, static mode of calibration of the pressure sensor. But since it is based on the algorithm, so it required dynamic mode of the calibration. But ISO, as I told you, 81060, which we have now, I believe we can do that part. So that is, the requirement for the dynamic mode of calibration for all the, BP devices, which is having not visual, like if you have the, non-automated devices, then it's perfectly fine for the R16.1. Even they have done recommended of the non-invasive automated sphygmomanometer for the OML R16.2, but what I feel at present, with the lot of development worldwide, this particular idea is not sufficient enough to have the type approval or testing for this automated oscillometric waveform based devices. So I'll hold my talk next time. Next is in order to based on the ISO 81060 because that is the demand of the worldwide NMIs, and every country is requiring to standardize their equipment based on this ISO. Means you have to check their dynamicity based on that particular guidelines. So next slide please. So let me few words about this our R16.1 and 2. what is the normal protocol? Protocol is, if you want to have the non-invasive, automated blood pressure devices, then you can have in the line, you have the two sphygmomanometer observer, and then you have the devices which is also in the line, and then you have the reference pressure point also, which is calibrated, having the SI traceability. So whatever you will generate, and there are various parameters that you have to follow, various environmental conditions, that is 20, around more than 20. And that once you'll go, this is if you'll Google it, you will get R16 1 and 2 PDF is available on the web page. And then everybody knows you have to follow all the 20 parameters for the type approval, including the electricals and other parts also. So this is the one way. Another way, you have the automated devices, and you have the another pressure, reference pressure gauge, and with the known volume, like they have already defined 500 ml of this particular volume with plus minus 5% error or uncertainty, and you can generate the pressure manually, and then you can compare these two devices, comparing method, and that's the procedure is given in R16 1 and 2, related to either automated or non-automated devices. But my talk will start from here. This already we have done and delivered to the legal metrology, and they are now competent enough in order to do all the things, and they have also given us like NPL custodian for this type approval. So but I hardly see somebody is coming from the industry. Let's see, that is another point, because here it is point of discussion related to the development. Next slide, please. So I would like to talk about our role. Like I belongs to National Physical Laboratory. So certainly as an NMI, my job is to develop, SI traceability, SI traceable system, which can calibrate or give testing or type approval for all these blood pressure devices. For that, what we have to do, we have to develop our own pulse generator, and then we have to develop an NIBP simulator, and then that we have then all digital devices, and the hospitals and the legal metrology all come to the point, and the common people. So traceability will go from top to bottom, and then it is mandated to the NMIs that we should develop a device that should based on the ISO 181030, and then develop simulator which have all the capability in order to testing the automated BP devices. So this is the what traceability chart that we have in our mind, and that is we are working on this. So yeah, next slide please. So this is very, this is the equipment that we have delivered the RRSL Faridabad and the Varanasi to the legal metrology department. And I hope the officers over there, they are using this, and if they have any problem, we are happy to solve any problem. But this is very beautiful device. It can calibrate 20 BP devices at a time, and all automated. That's image processing is there, and then they can take the data of the devices, and then it can be disseminated to the uh, collect the data, record the data, prepare the chart, and all the things that is, So, and we have also provided the climatic chamber, which is a requirement of the R16 1 and 2, and that is there. So these are the things that we have already delivered, and if anybody want, you can visit NPL. We have one device here in NPL also, and there also. So you can go and you can have any kind of type approval and testing approval that can be done over there. Next slide, please. And this is important for the Ashutosh ji. I think he went somewhere, but still. So we have procured, right now we do not have the NIPP's own designed or developed simulator, but then we procure this simulator from the Fluke, and then we have established and given the SI traceability, and we have checked how to calibrate this simulator, and this is really working very fine for our research purpose meantime. And then we can dynamically also calibrate any blood pressure devices. So now no more problem related to this. But then this is problem for me, as a NMI. I cannot go for key comparison having the known waveform with the market simulator. We have to develop our own simulator, which can generate, electrical pulses with the known amplitude and the shape of the pulse. But then we need data. Where is the data? Where is the clinical trial? Where is the oscillometric waveform? So based on that waveform, suppose that my waveform and Ashutosh ji waveform and Dixit Sahab and Vineet Sahab, waveform will be different. It may be having the blood pressure. We are all healthy people, so we can have the same BP maybe range also vary. But then we need a pool of data where in order to develop our own simulator. So next slide, please. Then I'll show you what we what. So for that we have to have the algorithm which can use the pulse generation and the various simulations and the process to check the authenticity of the pulse used to the measured blood pressure. So we have various conditions also in coming slides. So what we have done, we have checked in the simulator, we have already control on the pulse volume, where we can vary pulse volume from 1 cc to 2.4 cc. And the healthy heart human being having normally 2 cc per mmHg. So that is the requirement. So then all these things required for in order to design and develop the simulator. Can you go next slide? So this is the condition of the Chris Korea, which has developed their own simulator having the servo motor, and the valves is connected. Earlier they have used the piston gauge, but that is not generating the proper pulse. This servo motor is using good accurately to generate the pulses, and they have connected this in the line with the cup and then the BP devices, and using this particularly they calibrated, and based on that you can see in the left hand side down, this is the generated pulse where oscillometric waveform by their simulator. And then this is the way they have, I think that time we do not had the capability to generate this pulse. Right now we have. So we have not participated the key comparison they initiated in 1890. I don't know whether they have started or not, but I have to talk these two guys. If it is not, then I would like to participate that part also, because that's the authentication of our validation of our instrument and validation of our data acquisition. Next slide, please. I have not included many other NMIs. It's similarly the ITI Taiwan and this and that. So next, if you'll have look, so now 3 point is now. So first we have to develop some recorder which can record the oscillometric waveform for a pool of if you want to simulate the data. So if you want to generate the algorithm, then we need the oscillometric waveform of the Indian citizen. So for that we have to develop some pressure sensor which can really acquire the data. So one of my PhD student, he has developed some fantastic, pressure sensor, and this is flexible pressure sensor with the hyperbolite. And we publish many papers. You if you Google me, I think we have published more than 10 papers on the different type of the pressure sensor. I am giving only one example because talk is completely different. I'll not talk about the material science and the development of that. So we developed some sensor, and you can see with the change in the pressure, there is a change in 100% change in the capacitance. So this having the high sensitivity. So if there is a high sensitivity, so whether this can sense the human blood pressure. The next challenge is whether this device can sense the human blood pressure. Then only we can acquire the data. So next slide. So these are all science that we have did it, and so I'll tell you yes. So this is one of the graph that what we have obtained from our developed pressure sensor. So if you'll have look this, this oscillometric waveform, this was acquired given by the oscillometric waveform, a non-oscillometric waveform to the sensor, and the sensor what we got it in the sensor, this is 1210. Okay, so this sensor, then what we have developed, we acquired this sensor, we acquired this oscillometric waveform from our sensor. So this is very interesting. So what we found, we are able to get this oscillometric waveform from our indigenously developed, in-house developed pressure sensor. So that was encouraging. Next slide, please. And this is all about we have given the this particular. So next is whether this is the machine is not a perfect human being. What is the simulator is artificial human heart which is generating a pulse, but the real human heart having the different. So we have tested many things in order to using the simulator as well as the human being, then only we'll know we can acquire the clinical trial data. So we have mounted that pressure sensor on the mandrel, and then we attach with the computer, impedance analyzer, simulator, BP monitor, and then we acquire the oscillometric waveform. Because as I told you, and first started with the simulator, because first we have to give a perfect pulse, which is already the electronics is giving you. So 120/80 and the related pulse will given to the sensor, and then next slide, you'll see the data. You'll happy to see this kind of oscillometric waveform we are able to acquire. And now then what we do, we smoothened it, and then the zero it, and then the base ground correction, and many other things that we have done our own, and that is part of our investigation. And then we have developed our own envelope. And from this envelope, we are able to make a algorithm which can give the perfectly, systolic and diastolic pressure. So next slide. So this is a very interesting data. You'll see the reference. This is the data. This is the pressure that we have given by simulator. 120 mmHg, 80 mmHg, and 93 mmHg. And what we computed from our sensor is 117 mmHg, 83 mmHg, and 97 mmHg, 93 mmHg. So our sensor is absolutely giving perfect, even the using the machine, it is matching or following the international protocol of the reference value. Reference is, we consider reference as a simulator, and then we found our sensor is giving perfect value. Next slide, please. So I think those who are the participant, they should know about the how you will decide your equipment. As I told you, the ISO 81060 related to that, they have a protocol of the device. If you want to check it, then you have to draw a blend ultimate plot. What is the blend ultimate plot? You have to compute the systolic blood pressure with respect to the reference, and you have a draw a line, and then you have to compute the error also, and then that error, its error should be less than plus minus 10 mmHg. The most of the 95% data should be in between. Then you can say your device is perfectly fine, and it is not ready to launch in the market. So then this is all we did for our sensor, and then we found our sensor is matching with the international protocol. This is about the sensor. Next slide. Because time is now 12:15, so I have to go fast because 15 more minutes. So this is all about really different mean artery pressure, systolic pressure, diastolic pressure. We did thorough investigation for the different parameters of the blood pressure, and we found the sensor that we have developed and PLI has developed, which is meeting the international protocol, because then we have to do all the calculations and other things. Next slide, please. Next slide, please. Next slide. Yeah. So then what we did, we have attached Omron, which is Omron blood pressure devices, which is available in the market in the line of that particular investigation. And then we compare these two devices, sensors and the devices. We found in this condition also it is matching our devices. So all three are matching for a kind of comparison. Next slide, please. इसके बाद वाला भी स्लाइड सो वही है, सेम चीज है, बट देन आई एम टेलिंग यू कि वी हैव इन्वेस्टिगेटेड मेनी थिंग्स, not only with the simulator, but the Omron BP monitor, many other monitors, and we found whatever sensor we have developed, which is useful and can be used for the blood pressure measuring devices. Sensor is very much. Next slide, please. So we have now developed the sensor which can be used. You can see the international protocol, sensor versus simulator, sensor versus Omron, and all within the range of the international protocol. The protocol is the error should be having the 5 mmHg, and the standard deviation is plus minus 8 mmHg, less than that. So you can look at this, all is matching in between that. Only a small errors are there. Yeah, please, next slide. So so how discovery, you have to work very hard. So one stage clear, then next stage, then the third stage is, although it is very fine, we are using the artificial, so our NFM simulator is artificial, so next is whether these BP devices which is existing in the market can really give the correct BP for a patient which is sick or is having the severe illness, having respiratory problem, having arrhythmia or anything else. So then we did a lot of study in that, and we use, there are two devices BP monitor in that, and we use a highly accurate pressure sensor traceable to SI unit in the line, and then we generate the same condition from the simulator. We have not used human being, because human being is very variable. So first we want to check it from a fixed things which is non waveform for a sick value, and then whether it is right or wrong. Can you go next slide? You'll see, you'll surprised to see, I'll give you some data. So what we found, for sinus rhythm. Sinus rhythm means general and healthy people, normal people. Then we found both the devices, device under calibration. One is from the, doctor lab, doctor, what is the doctor? This is some doctor's, equipment. Another is from the Omron company, Dr. City Labs or whatever be. So these two devices we have taken the very accurate devices, and then we found that these two is working beautifully for a person, for a healthy people. Then what we check? Next slide, please. Then we programmed for different value of the volume variation. We change the variation. As I told you, human health is very good if we have the volume or pulse volume ratio is 0.6 or 0.7 of mmHg. But then we vary the pulse volume. If you vary the pulse volume, then we found it has the very different behavior of these two devices under calibration. Can you go next slide? So this is the conclusion of this. I'm there device under calibration 1 and 2. You will see here, if the pulse volume is less than 0.5, the device calibration 1 is having the mean and standard deviation is larger than the 5 mm of Hg, means this device failed to provide the real blood pressure for a person is giving pulse volume less than 0.5 0.6 cc. It means it cannot diagnose or it cannot give the correct blood pressure value for a unhealthy people having problem in this. So then we did the similarly for the another diastolic, systolic and diastolic measurement. Next slide, because this is all science. So the thing is, general thing is that what we found, look at this. This is patient condition. You have a healthy patient, both devices pass in the international norms, no problem. But a person who is weak pulse, you can see a device under calibration 1 is failed. It's not giving the proper international norms. Similarly, if the person having the obesity, this failed. Similarly, we found if the geriatric, and these are the well designed or defined human blood pressure oscillometric waveform. A person having obesity, their pulse is like this, as we have generated this pulse from the simulator. And then we found like tachyardic data and bradycardia, trachycardia, and even the trachycardia, even device 1 is not able to see the things. So what I found, device 1 is completely failed out of a scope. It cannot be used to measure the blood pressure. It cannot be used for the blood pressure for this kind of patient. So what is the conclusion from this slide? We found these two devices is only good for measuring the blood pressure for a healthy person. But if person is really sick and having, uh, tricardia, bradycardia, obesity, these devices, at least device 1 is not at all suitable for, these two for the blood pressure measurement. So this is one point that I would like to, and it will be helpful to you guys also, those who are legal metrology. Is so that you understand ki, so most of the devices are not good for a person which is unhealthy. But then it's failed to you can say follow the international protocol. Yeah, next slide, please. Next slide. This is all I have discussed. Next slide. You see, this is the two oscillometric waveform for the arrhythmia and the respiratory problems. So this is all about we have to develop. This data is taken from the simulator from the supposed NY fluke. So I have to find out some person which has really arrhythmia, and I have to collect their data, and I have to feed that oscillometric waveform of the Indian citizen having arrhythmia in our simulator. Then only we can design our algorithm. And this is similarly for the, so this is our in process. Next slide, please. So this is also all about, I told you these devices failed in order to international protocol. They failed to follow the international protocol. If a person having arrhythmia so these are the things that is we have investigated. Next slide, please. So this is for, I think, legal metrology also. This, so what next? What next? Now we have our own sensor. No, next. No, next slide. Please go back. So then we did a study in our human, collect the human oscillometric waveform. So the device that we have developed, so now we remove the NIBP simulator and we put the human being. But as you know, for the clinical trial, we have to take a lot of permission here and there, and that is right now not in my, I have to check my device first, then only all the things. So I have taken all this data taken from the NPL staff, that is within our limit. So undertaking we have taken, and this data is taken from the 100 or 200 people from the NPL staff. And then we collected all the data and the oscillometric waveform, and then computed the systolic and diastolic blood pressure also. And then we found, you can see here, most of the NPL staff is healthy enough. It's diastolic blood pressure is 80% is having the normal, but some of them having the very high. Some they know they have really high blood pressure. So one guy got diastolic blood pressure 120 mmHg, and some of them also having high 2-3. One person in NPL staff, we found the systolic blood pressure there is 220, and then we found he has even the really serious problem in order to have the hypertension, and then other part we have done. So what we conclude here, whatever sensor that we have developed, which is and whatever algorithm that we have developed for the calculation of the systolic and diastolic pressure, meeting the international norms of the systolic blood pressure should be 100% in the limit agreement. In our case, diastolic is 96% of the data is within the limit, and mean blood pressure is 94.11%. So what we conclude this sensors is quite good for real subject, real human subject. We have investigated, right now we did lot of investigation based on the simulator, which is artifact, but then we done on the human trial, and we found this is working very fine, absolutely fine for the human being also. Next slide, please. I think time, because we have limited time, so that's fine. This is the device that we have developed. This device is known as the blood pressure recorder cum monitor also. Monitor means the device which is in the market, and the recorder means those Omron or any device in the market, they will not record the oscillometric waveform. What they do, they simulate the data, and then they will give you systolic and diastolic blood pressure. But this device, and this is almost, not almost, 100% ready, then I am able to demonstrate this. So those, if suppose if you are really interested in real measurement of the human blood pressure in this India, so this is the one of the example of one of my PhD student who has done day and night last 6 months in order to develop this equipment. And this somebody want to technology or something related to this, most welcome. We are in process of that. So we have this. So what is the difference between the existing blood pressure devices in the market? So this is the recording. This will record the oscillometric waveform of the human body. So this can be used for the research purpose also. Similarly, after the algorithm that we have taken from the human citizen, although this is not the real clinical trial, but the data which we have taken from our citizen or our NPL staff, based on that we have developed algorithm. We have also developed algorithm based on the sum of the data taken from the simulator, and then we design and develop this. And then you can see the right hand side of this. Only you have to put the cuff on the upper arm of the human body, and then you will put the start button. You will get the systolic blood pressure, diastolic blood pressure, mean blood pressure, and heart rate. Okay, but this is very large screen, because we have developed this for the research purpose. So one is the research, as well as it will also give you the real blood pressure of the algorithm which is developed by the on the Indian citizen. So three things: it will record, and the data is taken based on the our clinical trial, and it will also provide a lot of things. Next slide. So this is the block diagram. Everything is done by ourselves, nothing else. This is one of the beauty of this equipment. We design block diagram, we have developed, we bought electronics from our own pockets, and then we design, develop, a lot of things we have done, and he done a really good job. And then next slides, all this, pressure sensor, and then now you can ask me question: how good is your this devices? Now you can ask me. Go back and first slide, please. Go to first slide. Yeah, no, next. This is. So then we checked our developed technology using the simulator, and we gave in known pulses of the different systolic and diastolic. And you see the last international protocol is 5 mmHg. It's matching 100% with the simulator data which is giving on this. Now you can ask me, okay, then your device might be, you have done a lot of research on simulator, that's why it is matching. So go next slide. So then we have done the most of the data taken from the CSIR staff using this technology. And then you can say error in the, this is very perfectly fine, because it's a human body. It will get, if it is at constant position, then it has some problem. If it has the large scattering, means device is taking the real data, and the systolic and diastolic pressure, sorry. So systolic and diastolic pressure is well within the international protocol, and their error is also quite good. You can see the error is 0.51, and even the standard deviation is large, but well within the international protocol. Similarly, for diastolic, it is very fine, but systolic. So you have to match again. By the way, we have now limit. Still, we have only the 60 subjects. We have not a lot of large pool of data. So this will be more more accurate if we have more large pool of real data. So that we are trying to get it. Next slide, please. So this is a video. Can you click it? Whether are you able to run the video or not of the devices? Can you click this? Yeah. Increase the sound. I think I cannot hear the sound. So, so the last slide in the last, you saw the oscillometric waveform pattern. You saw the, so this is all compact, but this is the first need as a NMI. This is my requirement, our requirement. So then we have developed that one. But this is exceptionally good for any research institution who want to have a clinical trial on various aspects of oscillometric waveform. This device will be, I don't see anybody having in this neither in companies making nor in India it is available. So this is one of the thing. And you saw the, we can acquire the oscillometric waveform, and based on that we have developed our systolic and diastolic pressure. So again, I would like to thank all of you, and especially Dikshit Sahab, Ashutosh Sahab, and then the Vinay everyone, giving, this opportunity to talk about this development of oscillometric waveform and recorder, as well as a recorder. I don't say now recorder, it's a recorder come, blood pressure monitoring devices. So you have now accurate blood pressure values based on our own algorithm, based on our own, Indian citizen oscillometric waveform data. Thank you very much.
Thank you very much, sir. It was a very nice presentation, and we have with us Dr. Raut and many other participants who are very well working in this medical devices field. Sir, I hope that we have a few questions. If you kindly take with
Yes,
your
any question, anytime, no problem. That's for my pleasure. I always love have question. Discussion will only that not only that improve. So I would be happy, to answer any question related to this or unrelated to this also. I'm giving big scope. They can ask any question.
how good
If I know the answer of that question, I'll tell them. If I don't know, I'll tell, excuse me. That's not the problem. Yeah.
sir, how good are the blood pressure applications available online for download and measurement. How good are the blood pressure applications available online for download and measurement?
For download and measurement, this is question from your side or from someone else?
Sir, some of the participants have this question in the chat.
So actually, the question was there are a lot of, as you mentioned, people are having the wrist devices and other things, and they can be possibly attached to measurement application software. So
Yeah,
there are
yeah.
softwares available,
No,
and
no,
what
I
is
understand because this is not actually. I have today. I have not discussed about the cuffless devices or smartphones and their application software and all the things. Look, I can answer this also because I understand most of the things because I am working on that aspect of also for the coming. One of my PhD students is working on that. So really, at present in all over world, there is not a single standard which is available in the market for real validation of this. ISO, as I told you, ISO 81 version 3 is dedicated to the cuffless devices. Still, it is not in the market. They are working on they are optimizing the things, but that is not, implemented anywhere. So how good or how bad, once a standard will be there, then only you have the comparative study. Each company, they will claim ki my BP, whatever devices I have developed and the value it is giving is it's perfectly fine. And you have to understand that. But the validation part and the realization part, only if it is validated, without validation has no meaning. So this is the work that we are trying. Still in India, I'm telling you truth, and Ashutosh ji is here. Still, we are not doing the proper way to do the even automated blood pressure devices, which is based on the oscillometric waveform. Okay. So this is all. If you'll ask me question related to the cuffless devices, smartphones, smarts, things. That is, it's not right now available in the market, and reliability part is very. I can say everyone having own parameters, not international protocol. So no international authentication or validation for sure right now. So each company, suppose that iPhone is having the devices iWatch, and they are also giving the blood pressure value, but they are their own technology and techniques they are using, but not internationally accepted. If you trust on them, it is well enough. If you don't trust, no way to say it is right or wrong.
Sir, how a person can confirm that a BP measurement by a digital monitor is okay or not?
Look, person, I have, I think in some of the slide I told, ki, this is your job and my job. Some equipment is in the market, whether that is right or wrong. Person do not have a gadget to check whether it is right or wrong. Person can go for alternative things, like suppose that I'm giving one example. You have the digital blood pressure, and every time that is giving you 160 170 your blood pressure, and you do not feel even the blood pressure, you have the blood pressure. What you will do? You have to go the gold standard. Go back and check your blood pressure with the mercury base sphygmomanometer. And if that is also giving you, because that is visual, and the visual as well as your audio, visual and audio, not related to the electronics of the oscillometric waveform or automatic devices. So if one person is really sick and they feel they are very happy, and his machine is every time giving 170 90 or 170 100, immediately they should check with the sphygmomanometer and with some trained people, not by themselves, because the audacity should be good, because they should hear the systolic and diastolic blood pressure. and from there they can confirm that their device is giving the right or wrong. But if the device is giving error within the limit, as I showed one of the slide, ki Canadian professor, they have conducted the experiment and they found the 5 mmHg of the difference make 8% population to 18% population of having the hypertension. So that is the job of a legal department. That particular equipment should not go in the market, and that cannot be even the counter check by these gold standard also, because human blood pressure is varying a lot. So the first check is that is, as I given you all the examples, all the oscillometric waveform devices required validation with 5 mmHg of error, along with the plus minus 8 mmHg of the standard deviation in the error, in terms with respect to the reference devices. Reference is either simulator or reference is developed by any way by any NMIs. So this is the ISO protocol, and you know well about the R16N1 and 2, that having the different criteria, that also one can validate. Yes, yes, please.
So next question is,
Your point, 1 minute, Ashutosh. Dr. Saab, points are very correct that everybody must have the master meter and they must calibrate their own blood pressure meters and then it should be used. But in India, the people are going to the foreign and they are purchasing the different brand who are very popular, and then in hospital they are directly using, the doctors are using them very directly there, on the belief that this is the branded company and that blood pressure meter will be very correct. This is the one things. And another thing is that this mercury thermometers, mercury blood pressure meters, now this time I think has been banned in the hospital. Nobody is using the mercury blood pressure meters. So these are the two important thing. Other thing is the digital. Now you see that even in the wristwatch also, you might be getting the blood pressure machine, and that is always giving your blood pressure and all that type of things. That is never being controlled. But people are being using that very things very frequently. So I want that Dr. Saab should make the comment on these three issues.
Yes, sir. So actually, you are absolutely right. The mercury based this is already banned in most of the developed country, but still it is considered as a gold standard. But this cannot be used as a general audience. For us, suppose that if I want to validate something like OML R16 1 and 2, how it's a validation of our one thing. Suppose that as a NMI, if I validate something, then that particular can be disseminated all over India. About the person, first question was your ki somebody is going outside, they can buy the high gadgets and they think this is fine, like you have the Apple Watch or many other watches having giving you the blood pressure and all the healthy parameters. But that cannot be conclusive as a point of a researcher or as a point of a as a NMIs or legal metrology. People are doing what they want to do it, but that is not
A
within your
researcher
control.
cannot do it, but as a person, people believe that these measurements are very correct.
Yeah,
These
yeah.
are
So
from the branded
yeah, you
companies.
are right. So then I
Uh,
have shown one of the data.
and sometimes the doctors are also telling them that you have the blood pressure now, you should have this type of wristwatch with you so that you can monitor your blood pressure every time, and when you are having any issue, rise in the blood pressure or decrease in the blood pressure, because the lower blood pressure is more dangerous than the high blood pressure. So you can visit immediately, and your means health may be observed by the doctors. So these are the three, four things are there. I understand this mercury blood pressure meters. These are the laboratory standards, and earlier it was used by the doctors also. But in hospital it has been banned. So doctors, they are not able to use that very things.
Exactly,
And
exactly. That
you find that that in hospital most of the these blood pressure meters are not being calibrated,
yes,
even from the scientific agencies,
yes, yes.
and we are just moving that scientifically we are very correct.
Uh,
Uh, because I also support you, because you are our NMI and all that type of things, and we are legal metrology, and we are calibrating our all standards from the NPL, and then only we are calibrating to the others, or even giving the model approval certification and whatever the things are there. Only that standards is always calibrated by the National Physical Laboratory. Then only we are using. Otherwise, we are not using.
yes, yes,
But
that
the
is.
market situation is
Yeah,
very
yeah,
different.
limitation is everywhere, but as a NMI or as a legal metrology, I think we should aware about whatever you saw in my talk. We did a study on two of the well-renowned, blood pressure monitor, digital one, and what we found ki both are failed in terms of having a person arrhythmia and many other obesity or some of the diseases having there. So this is that we have to aware, because it's going on. Omron is one of the everyone is using. Doctor Lab also everybody is using, and both are failed. And failed means failed. We are going to publish that. That is fine. But thing is that awareness will come. Doctors, they are using all the digital part, and that is also because ISO permit us, because we do not have the capability to develop, like right now we should have the our own algorithm like clinical trial data, and that is lacking. We are lacking in that particular field. Doctors should also do, some of the doctor should involve in these kind of study. They should get the collection of data, oscillometric waveform data, to make a better algorithm for Indian citizen, and then we will get the digital one is the correct one. So that is, you are absolutely right, there are many things
To
is
be
going
calibrated.
on. Yeah, and it is not beyond our control, because it's bismarck country, everybody required, and then we have limited facility, labs, understanding also. So
Sir,
all those things,
Sir,
sir.
one other question is
sir, you
how
have the
digital.
journals and all the things. If those journals, all these things will be prescribed in nice manners, I
Yes,
think the problem may be resolved.
yes, 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 that is there, that will be there.
So there is a requirement of legislation here, or maybe rules to be brought. What kind of meters are sold in the country, whether they are capturing the oscillogram wave and other things, or they are only giving. Then there is an issue what Dr. Ashok Kumar mentioned about the Indian patient data. That's they are not calibrated, or they have not been designed on the standard deviation of the national information. And he mentioned about the practical problems that he was to get only data from the NPL staff to even develop the latest technology which they've done. And so there are practical issues where the industry has to come forward, the medical fraternity has to come forward to share that information and data. and then probably an Indian maybe mechanical and electrical or electronic device can be developed there,
Yes.
which can be then used appropriately for the Indian population.
Right.
He has NPL has already developed one simulator and pulsing mechanism, and he has offered that for the industry that if they wish, this transfer of technology can and it can be replicated maybe economically for commercial use, then a lot of people should come forward to at least use this, which is a simulation there, and then there is a measurement and a recorder showing those measurement readings. So large part of interaction needs to be done. We can bring in the stakeholders here, who can be the medical doctors, and some data on like the areas he shared, people having obesity, other tachycardia and special problems, what sort of measurement or simulation is required there, and what kind of a wave and a pattern is observed in the Indian conditions and Indian, let's say, people with their kind of constitution. We need to probably capture that information to refine the digital meters or any other meters which have to be marketed in India.
Right.
Since there is a gap, Omron is coming or any other company is coming for that matter, and people are using whatever is available, and some are reliable as he has shown in certain conditions, but many may not be. So I think there is a gap there, and Ashutosh ji will address this. We'll have a stakeholder meeting on this.
Thank you. Thank you
Other
very much, sir.
questions you can raise, Ashutosh, if there are to the guest speaker, sir.
Sir, thank you very much, sir. Sir, one of the participant is asking how digital BP apparatus are authentic, which are currently available in the market. What is the criteria to purchase and use as an authentic gadget? So again, we have discussed a lot. The next is what is the calibration procedure to calibrate a digital BP monitor meter? Obviously, we have the digital calibrators. With the help of those digital calibrators, we can calibrate these BP meters. So these are the very few things. With this, sir, I would like to thank our Joint Secretary, sir, Shri Vinit Mathur Sahab, and our Professor Ashok Kumarji, who is here from the National Physical Laboratory, Shri Biyanti Sahab, all the participants, and NIC team, Mr. Santosh Kumar, who has made this program successful. Thank you very much, sir. Thanks a lot. Thank you very much.
Thank you. Thank you.